We are going to begin some right triangle trigonometry today. The first thing we're going to look at is the sides of a right triangle. If we have two sides of a right triangle, then we can find the third side length using what's called the Pythagorean theorem. So the Pythagorean theorem says that we know it better as a squared plus b squared equals c squared, where c is the hypotenuse of the right triangle. The hypotenuse is always across from the right angle, and a and b are the legs of the right triangle. The legs of the right triangle are the two legs that are the two sides that are adjacent to the right angle. So we'll start with number 1. If we know the two legs, then we know that 9 squared plus 12 squared is equal to r squared. 9 squared is 81, and 12 squared is 144. And if we add 81 plus 144, we get 225. So if r squared is equal to 225, we can take the square root of both sides, and normally we would put plus or minus, but in this case, r refers to the hypotenuse of the right triangle. So the length, it's a side, it's a length, so we only want to make it positive. And the square root of 225 is 15. So the hypotenuse of this right triangle is 15. So we can do the same thing. Let's go to number 3. We can do the same thing if we're missing a leg. We can say that, let's start with A. So we'll say x squared plus 6 squared is equal to the square root of 85 squared. 6 squared is 36. And the square root of 85 squared is just 85. So if I subtract 36 from both sides, 85 minus 36 is 49. So if I take the square root of both sides, then I get that the side of the missing side is 7. Okay, so if we are looking at our special triangles, our 45, 45, 90 triangle, which is we have in number 4, and our 30, 60, 90 triangle, which we have in number 5 and 6, then we can find the unknown side lengths and then find the sine, the cosine, the tangent, and then also the other 3 trig ratios, which is the cosecant, the secant, and the cotangent. So we'll have to review that. So let's start with remembering the ratio of the sides of the 45, 45, 90 triangle. I'm going to go to the side and let's draw a 45, 45, 90 triangle where the side lengths are, we probably learned them as either n squared of 2, or a squared of 2, or x squared of 2, something like that. So we're just going to know it now is if we look at the ratios, it's always going to be 1, 1, and then square root of 2. So we're going to need to remember this as our sides of our 45, 45, 90 triangle. And we can also draw a 30, 60, 90 triangle. And we remember that as probably, I would imagine, n, where the hypotenuse is, across from the 30 is n, the hypotenuse is 2n, and across from the 60 is the n squared of 3. But now that we're a little bit bigger, we're just going to remember it as across from the 30 is 1, the hypotenuse is 2, which means that the hypotenuse is always twice whatever that side is. And then across from the 60 is the square root of 3. So we're going to box these so that we remember these ratio of these sides. And that's going to help us a lot to determine the sides of our missing lengths, our missing sides on our 30, 60, 90 triangle and our 45, 45, 90 triangle. So I'm going to go over back to number 4, and I see that the hypotenuse is 1, and I need to find x and y. So 1, that's my 1. Remember, that's my, so that's my n, and that's my n squared of 2. So I can say that x is equal to, or n, I can say that n squared of 2 is equal to 1 in this case, which means that the n, which is our x and our y in this case, is 1 over root 2, or root 2 over 2. So x is root 2 over 2. X and y are both root 2 over 2. And so we remember the sine, the cosine, the tangent ratios. Let's go over to the side and make that note. So the sine of an angle is the opposite over the hypotenuse, and the cosine of an angle is the adjacent side over the hypotenuse, and the tangent of an angle is the opposite side over the adjacent side. So that's our SOHCAHTOA, sine, opposite, remember, SOHCAHTOA. That's our sine is our opposite over hypotenuse, our cosine is our adjacent over hypotenuse, and our tangent is opposite over adjacent. And so we also have the reciprocal of those trig ratios. Those are called the cosecant, the secant, and the cotangent. So 1 over the sine of theta is known as the cosecant, or abbreviated CSC. And 1 over the cosine of theta is called the secant of the angle, or abbreviated SEC. And 1 over the tangent of an angle is called the cotangent, which is abbreviated COT. Okay, so if we go back to our problem, we know that the sine of theta is the opposite over the hypotenuse. So the sine of where theta is 45 degrees, it's going to be square root of 2 over 2 over 1. So just square root of 2 over 2. And the cosine is also the adjacent over the hypotenuse. And since the opposite and the adjacent side are the same, it's still root 2 over 2. And then the tangent is the opposite over the hypotenuse. So that is square root of 2 over 2 divided by the square root of 2 over 2, which is just 1. And so the cosine of, the sine and the cosine of any 45-degree angle will always be the square root of 2 over 2. And the tangent will always be 1. And so to get the cosecant, we're just going to take the reciprocal. And remember, the square root of 2 over 2 was 1 over the square root of 2. So 1 over the square root of 2, if we take the reciprocal, it's just the square root of 2 over 2. Square root of 2, over 1. And the same thing with the secant. So the reciprocal of 1 over the square root of 2 is the square root of 2 over 1. And the reciprocal of 1 is 1. Okay, now we can do number 5. We can do our 30, 60, 90 triangle. We remember the 30, 60, 90 triangle. Let's see, I want, if our angle is 30 degrees, we can use this triangle here. Our angle is 30 degrees. We can use that for sine, cosine, and tangent, but we need to find our missing sides. So in this case, we have the hypotenuse, which is our 2n, remember? N, 2n, n squared of 3. So we're given the 2n. So the 2n in this case is 14. That means the n is 7. So across from the 30, which is our y is 7, and our x is that number times the square root of 3. And to get our sine, cosine, and tangent ratios, we can use our little triangle over here, our 30, 60, 90 triangle, or I can just rewrite it up here. Let's rewrite it in a different color. So across from the 30 is 1, the hypotenuse is 2, and across from the 60 is, there's the 60. Across from the 60 is the square root of 3. So I can use that to get our sine, cosine, and tangent ratios. So the sine of 30 degrees is the opposite side. So from the 30, the opposite side is 1 over the hypotenuse, so 1 over 2. Go back to black. And then the cosine is of 30 degrees is the adjacent side of the hypotenuse. So the adjacent side would be the root 3 over 2. And our tangent would be the opposite over the adjacent. So the opposite over the adjacent would be 1 divided by the square root of 3, which is the square root of 3 over 3. And then we can find the reciprocal of 1/2 to get our cosecant, and that would be 2. And we can find the reciprocal of our secant. So our secant is the reciprocal of cosine. So if we take the reciprocal of square root of 3 over 2, we get 2 over the square root of 3, which if we rationalize, we get 2 square root of 3 over 3, don't we? And then the reciprocal of, let's see, we knew that the tangent was the opposite over the adjacent. So that was 1 over the square root of 3. And so the reciprocal of 1 over the square root of 3 is just the square root of 3. All right, I'll save you to do this number 6. Okay, so we can use our calculator to approximate to the 10,000th, tenths, hundredths, thousandths, 10,000. So that's 4 places. So we're going to approximate to 4 places, and we're going to make sure that our calculator is in degree mode. So when we go to our calculator, first thing we're going to do is we're going to go to mode, which is right by the second function button at the top. And we're going to go down to either radian or degree, and we're going to change it to degree. We're going to make sure we're in degree mode. So when we put in an angle in our calculator, that the calculator knows that the angle is in degrees. We can also measure angles in radians, but you'll learn about that next year. Okay, so what I want to do is I want to approximate the sine of 14 degrees. So I'm going to go to my calculator, and I'm going to put sine and 14, and I'm going to approximate it to 4 decimal places. 0.2419. 0.2419. Okay, and I can also do, let's dip to number 9. So how do we do secant? Secant, remember, is 1 over the cosine of 23 degrees. So that's what I want to do. So I want to do 1 divided by the cosine of 23 degrees. And it gives me the secant, which is 1.0864. Okay, that's easy enough, just using our calculator. Okay, so let's look at the next problem. Actually, we're going to skip that one, and then we're going to go to number 13, and we're going to talk about how we solve a right triangle. So we solved out any triangle by finding all the missing angles and all the missing sides. So it tells us that angle A is 37 degrees, and I know that angle C is 90 degrees from the symbol. So I can use my knowledge that the sum of the interior angles of a triangle is 180 degrees to find angle B. So I know that 90 plus 37 is 127, and 180 minus 127 is 53 degrees. So angle B is 53 degrees. So now I'm going to find the missing sides. So I have the hypotenuse. The hypotenuse is 22. So this is not a 30, 60, 90 triangle or a 45, 45, 90 triangle. So we're going to have to use trig in order to get our missing sides. So I'm going to find side A first. So I know this angle A is 37 degrees. And side A is the side that is across from that. So I want the side that is across, opposite, and I have the hypotenuse. So opposite hypotenuse makes me think of sine. So I'm going to say that the sine of 37 degrees is equal to A divided by 22. And then I'm going to solve for A. So I'm going to multiply both sides by 22. So side A is equal to 22. I'm going to go to my calculator. I'm going to do 22 times the sine of 37 degrees. And it's going to give me about 13.2. And I'm going to use the same method to find side B. So side B is the side that is adjacent to the 37 degree angle. Side B is adjacent to the 37 degree angle. So adjacent hypotenuse makes me think of cosine. So I'm going to say that the cosine of 37 degrees is equal to side B divided by 22. And I'm going to solve the equation from there. So I'm going to multiply both sides by 22. And I get that B is equal to, let's go to our calculator. We want 22 times the cosine of 37. Times the cosine of 37 degrees. And we get 17.6. And that's how we do it. Okay, we're going to do one more thing. We're going to talk about an angle of elevation and an angle of depression. So let's look at 16. It says to estimate the width of a river, Sally first stood directly opposite a large pine tree. So here's Sally, here's the pine tree way over here. Then she walked 35 miles along the river. So she was here, and then she's walking 35 miles along the river. So the length here is 35 meters. And estimated that the angle between her line of sight to the pine tree and the riverbank was 25 degrees. So this right here is our angle of elevation. She's looking up at the tree, and the angle of elevation is 25 degrees. We want to find the width of the river. So the width of the river is here, so we'll call that x. That's what we don't know. So we have our angle, and we want to know what the opposite side is of that angle, and we have the adjacent side. So opposite adjacent makes me think of tangent. So I'm going to say the tangent of 25 degrees is equal to x divided by 35. And I'm going to solve the equation. So I'm just going to simply multiply both sides by 35. and I'm going to go to my calculator, and I'm going to say 35 times the tangent of 25 degrees is about 16.3. So the width of the river is about 16.3 meters.